Thank you. Thank you. Can you guys hear me okay?
Yeah.
Perfect. So welcome. We're really happy to be here today. Before we dive in, I wanted to make a quick round of introductions. So Omar, our friend from AWS, why don't you go ahead and start?
Yeah, thank you, Arnon. So my name is Omar. I'm a security solutions architect at AWS, and I specialize in automotive security. So I work with some of the biggest automotive customers in the world, helping them secure their vehicles and enterprise cloud. And when I'm not doing that, I teach hundreds of students a year in university and training programs in cybersecurity. That's my passion. And so, Shakar?
Hi, everyone. Thank you for joining. My name is Shachar Azriel. I'm Vice President of Data in Upstream Security.
What do you do for fun?
Wave surfing and yoga. No waves here, but yoga this morning.
Well, Shachar is a surfer. Omar is a teacher. I'm blamed to be a CrossFit addict. So my name is Arnon. I head the business development here at Upstream, and I'm honored to moderate this panel today. So let's dive right in. When we talk about APIs, quick show of hands, how many of you know what APIs are? Okay, great. So APIs play a crucial role for OEMs in the last couple of years. They advance smart mobility. They enable effective connectivity between drivers and the cars, between servers and other machines. And they basically allow OEMs to expand their revenue streams. They allow new services, what's called the service economy. But on the other hand, hackers are more than ransomware. They're eyeing now trust. They're eyeing brand reputation. And when we're talking about automotive cyber attacks, it's not only about those nice things of white hats. We're talking about potential life-threatening attacks. And those APIs may be relevant. So we're talking about the move from over-the-air updates into SDV. So that means that we're going to see more continuous vehicle updates, which is great. But again, there's a big potential here. And we're going to talk about API security for being the key to securing not only IT, but also OT. And that's the big thing that we're talking about today. Now, there's a stat that I want to start with, right? By 2025, connected cars could produce 10 exabytes of data per month, which is basically 1,000-fold increase of what's going on today. Now, with that in mind, Shachar, we're seeing a significant growth of cybersecurity attacks. And we dedicate this session to API security. So why API security?
Yeah, so as you've seen at the first slide, we're talking about like a significant growth in connected cars and the bandwidth of data that they transmit to servers, the growth of services and the number of attacks that are growing. And we decided to put a spotlight on a specific threat vector and its APIs. And this is in the context of what we're seeing also in the conference and digital experience. So just to provide a short introduction about what are APIs. So APIs are the modern gate to your data. And today, more than ever, every company, if it's a mobility company, a fleet management, manufacturing, smart mobility, every kind of company that we have around is trying to be more connected, that their services would be more accessible. And the best way to do it is APIs. That's the standard way to do it. That's the most convenient way to do it. And mobility players are constantly trying to advance, and they identify APIs as the main engine to draw that change in their services and their applications. So on one hand, we have the fact that APIs are a powerful engine for change. But on the other hand, you can see that APIs pose a significant threat to those services, to the data. So two stats that I want to mention is, first of all, Gartner predicts that by 2024, the number of APIs in general will double. So that means that the threat doubles. And the second thing, from our perspective as Upstream Security, our research shows that API attacks tripled in the last 6 months in the automotive industry. So combine that's the reason why we decided to dedicate this specific talk to API security.
Okay, so Omar, if I wanna dive into the security, right? There's a lot going on about app security. Isn't that enough? I mean, I got my app security tight. Are we good there, or maybe not?
Yeah, so I think for me, my job at AWS is to help our customers implement foundational security. So my goal is to say, you're implementing APIs at scale. So these are the things you have to do. So these are things like shift left, create what we call guardians within your security program to help kind of do threat models the right way. And so this is like we call table stakes, which there's a lot of gaps there today. Like customers are not doing these things the right way yet, but they're getting better and better. I think where automotive is extremely interesting is now you have a vehicle, many vehicles in the field. You have lots and lots of APIs that do things to those vehicles. And now this kind of theme of this talk, which is what is the context around the security of your API. So you can shift left and you can do all the right things, but it's very difficult to determine whether or not a person, a consumer, or a vehicle is supposed to be doing those things, even though those may be secured, right? So this is sort of where Upstream and sort of our partnership comes in, which is how do you understand the context of your APIs beyond just protecting the fundamentals?
Yeah, I think context would be a hot topic today.
Our theme, for sure.
So moving on, if we look at automotive data modernization and we look at the subscription economy, everything is instant and users are used to do things remotely. So there's a smart home. Why shouldn't there be a smart car? I want to open my car. I want to get my seat warm. I want to get my car air conditioned. There are many ways that I can either interact with a car or users can interact with a dealership, right? So can you talk about how customers are using APIs in the automotive and manufacturing and give us a few examples?
Yeah, so I can start with that. So we sort of mentioned this already, but think of an API as the canonical example we use in the industry is a restaurant. And so the people eating are the mobile applications and the users. The cooks in the kitchen are the backend servers that take your requests. And then the servers that walk around, those are your APIs. And so ultimately, our goal is to protect those communications between the consumers and the backend. And so what are we seeing in automotive? You open your application, right? This is your front end, and you press a button, and then something magical happens to your vehicle. It starts, it locks, it unlocks, you get status about your tire pressure. Every single one of those calls are APIs. Those are API calls that are happening. So you, as an automotive customer, have to think about how do I secure each one of those APIs? And later on, Shakar is going to talk about how, but that's sort of what we're thinking about as a problem. But Shakar, you have more examples, I think.
Yeah, so I was just walking around yesterday in the conference and I tried to look at some examples and some booths. So everybody's talking about smart charging, right? Like I'm taking my vehicle, I'm plug and charge. Something magical has happened in the background. There's a transaction, that's an API. We're talking about fleet management. We have companies, mobility companies that have many assets. They want to track their vehicles. They want to plan the best routes for their vehicles based on APIs. So probably everything you're seeing here is driven by APIs. Every advanced service in the mobility ecosystem is driven by APIs. And we're going to go through more examples and more analogies that not only are restaurants.
Sure.
Fantastic. So everything is an API. That's the theme of our session. And I think that last week, I just got a DHL package delivering my new glasses. And the guy there, right, scanning the package and another SMS message that I just got, it's all right, driven through APIs, right? So, okay, why are automotive APIs so important and why have they become a desirable target for bad actors?
So, as we mentioned, APIs are the gateway to data. And when you look about threat actors and hackers, the place they go is where data is because they understand that data means money. So that's like the main reason why APIs is such a significant target. The second reason is the fact that APIs are documented and published. Let's say I'm a mobility company, I have a service, I want everybody to be able to connect to that service, to know what to expect when they connect to my service. So think about it that potentially I publish how to hack my system. I'm using it as a guide, from goodwill, but people can abuse that. And the third reason is the low technical bar. Comparing to things that we see in IoT, in the industrial area, in automotive, of hacking devices, hacking an API is hacking 101. It's really easy. It's something that people do to train, and therefore it draws a lot of attention of threat actors.
I think the second piece that I would just add to that is we talked about context being one theme. Another theme of this talk, I think, is also just availability or sort of ubiquity is the word we use a lot, which means it's everywhere. So APIs are just the cloud helps us accelerate development, right? So before it took us months to build an application, you had to do change management, run servers, go through your management chain. Now you can, on AWS, you can build an app in 30 minutes. You can deploy an API in 30 minutes. The trade-off there is that if you don't control those things, then you have the correlation between the number of features and then the number of APIs grow exponentially. And we're starting to see that happen in the data as well. More and more APIs, and ultimately what happens is you'll have a slightly larger security risk with each API that you're developing.
So let's talk about the attack surface, right? There's something that was really going viral, public, gaining more traction, right? The OWASP top 10. Shahar, can you guide us through that and talk a little bit about the risks in API?
Sure. So the cybersecurity community understood that API threats are tricky threats, right? It's not like don't connect this key to your endpoint device or don't share your passwords, and therefore we defined a standard in this community of how to deal with API threats, and there's a whole category that is called OWASP Top 10, and that is the standard to deal with API attacks. So the way I see it, and this is the example I use when I want to explain the API security flaws, is when you design a house, you build a house, you say, I expect people to enter the house through the door. I built a door that people will use it to enter the house. But there's a back door. There's a window. If you're in Germany, there's maybe a chimney that someone can use to get into the house. And that's API security. It's the fact that you design something, but people consume it in a different way. So just to give you some examples of these attacks. So one of the basic ones is excessive data exposure. So let's say a developer developed an API that is supposed to return data, and he just built one API that will return a lot of data. He used it just to get your first name and your last name, but he said, yeah, maybe someone else would use this API to get a VIN number of the vehicle, his social security number, maybe his credit card. I'm not going to use it, but it's going to be useful for other people. That is like the best present you can give a hacker, because like he's using that API now to retrieve a lot of data that he's not supposed to, and you can say, okay, that's like just the way someone designed it. He just thought he's only gonna use these names, and nobody's gonna manipulate that. So that is one example. Another one I would like to talk about is rate limiting, for example. So let's say I'm defining an API. I'm expecting it to get your first name and your last name. Let's say probably it's gonna be 20 characters. And that's how I expect someone would use it. Only put like first and last name. But let's say I'm a hacker. I want to shut down your app. I'm going to put inside a regular expression that takes hours to compute. And I send it through your API. And now I'm taking all your resources and I'm DDoSing your application. And the last one, and like I think all of us are scared of it, and it has like this bad name called BOLA. It's broken object level authorization. This means that the code isn't designed to validate at every step that the objects that the user is trying to access are really objects that he's supposed to access. So I'm going back to the house example because it's a hard one. Let's say I got into your house. Nobody asked how I got there, but now I'm in your house and I'm starting to open these drawers and cupboards and take things out and doing whatever I want in your house. And at any point, someone doesn't approach me and ask like, hey, why are you in your house? Because they assume that I got there in a legitimate way. And when we're talking about Bola, what is expected to do is before I access every drawer, access every cupboard, I'm asked like, hey, are you authorized to do that? And if not, I'm getting kicked out of the house.
I love what you did. So I have two visuals that I carry with it. The babysitter opening the drawers at the house. And then the chimney, I got Santa Claus, but not bringing gifts, but taking ones.
Yeah.
So if we're looking at the history, right? A quick look at the history. I think the history is moving really fast here. Can you take us through the last couple of years?
Yeah, so I think that if we would have this conversation 2 years ago, it will be theoretic, right? Like we'll say APIs, we think there's going to be a significant growth in that. We think there's going to be a lot of attacks because we're seeing it at the enterprise side and the IT side. But in the automotive industry, we're seeing this tremendous growth. So I'm taking you to like 2015, the area of hacking vehicles. So we have Charlie Miller that hacked a car. It took him 3 years to hack one car. And it did like a massive impact in the industry. Hey, someone was able to hack a car, like switch it off while it's driving. This is a big thing. Okay, one car. In 2022, we have a 19-year-old guy from Germany that is able to hack 25 Teslas using an API. So now it's remote control of the vehicle. It's 25 vehicles using one vulnerability. And then a year after, we have a researcher that is able to get access to 20 different OEMs, potentially millions of cars using one telematics and API vulnerability. So I'm not talking about what can be the implications of that, but you can see how these attacks grow. And first of all, you can see that one vulnerability is able to get access not to one vehicle, but to many vehicles and potentially hundreds of thousands of vehicles. And the second thing is the fact that the first attacks required specific understanding of automotive technology, like hacking the Jeep requires understanding of CAN bus. That is things that are really rare in the industry. While the last hack using API attacks, IT vulnerabilities, a lot of people know how to deal with that.
So moving forward, and I think above us we see more and more, unfortunately, real life examples of what happens out there. And it's not only the white hat hackers who are the good guys, right? They get the bounty for finding things. We're starting to see some bad actors on the rise, right? And it's not only about being able to get access, right? It's causing some real damage, right? And I want to emphasize, right, the fact that Siemens is putting a 1.5 trillion damage over business disruption. We're seeing business disruption coming as a big threat, right, to manufacturing. And I know that you guys were doing demos at the Upstream booth over there, showing how could a manufacturing API attack lead to such thing. Can you talk more about what's going on out there?
Yeah, so on every attack has a motivation, and that motivation is usually to get data or to tamper with something. So we talk about something in cybersecurity called the CIA triad, not the agency, but the fundamental concept is confidentiality, integrity, and availability. So almost every single attack is going to affect one of those things. And so kind of clearly in this slide, it's showing what does it mean to see a vulnerable API get targeted. You start to see attackers tamper with things. They can send commands to your vehicle that they shouldn't be able to send. So they're able to tamper with connectivity to your vehicle. They can tell your vehicle to do things. They can change routes. And this is a really big risk. So tampering is a big thing that we're seeing even in the industry happening in the real world, not just in research settings. The second thing, and most common, is leaking data, because it's quite easy. So you have a very simple misconfiguration, and then you get access to an entire backend, right? So single sign-on is not configured properly in your environment, and now you get to access private repos. You get to see access keys. You get to exfiltrate all kinds of data, and nobody knows any better because that API is working as intended. It's taking in a request, and nobody knows exactly who that person was or why that was allowed. So we're seeing that in the real world today. So really, confidentiality and integrity are very large attacks that we're seeing in the industry.
So just to link it to some impacts that we've seen lately, and I would like to focus on two examples. One of them is from the area of the manufacturing. So we have examples of shutting down production plants for one day and causing impact of hundreds of millions of dollars because of delays of production. So that is one potential impact of an API attack. And the second one is one that I think is like the next level of using APIs and using vehicles as a cyber attack means. So it's the Yandex incident, the fact that hackers were able to hack an API to taxis and send all the taxis to a specific area in Russia and causing a gridlock. So think about all of you in the morning trying to get to IAA and there's like massive traffic jams. Nobody can get to the conference. The counselor is trying to get here, he can't get here, and that is only using an API, and think how close it is, and we're already seeing it in the field.
How realistic, just thinking out loud, how realistic it is, because you're saying, sending people or sending drivers to the gridlock. We're seeing here very large, commercial vehicles, and those weigh tens of tons. How realistic it is that through an API, a hacker would be able to get control over such a huge truck? Is it something feasible?
The way I see it is we haven't seen those kinds of attacks in commercial vehicles because commercial vehicles are more conservative because they understand that people don't expect that kind of digital experience with their trucks. But as we see, there's much more connectivities in their area, and therefore I assume that as hackers understand the potential that they have in private cars, and as you said, like commercial vehicles are critical, then they will start aiming to that area.
Okay. Well, take us through I think this is a real life example that Upstream was able to mitigate.
Yeah, so we're also demonstrating this in more detail in our demo booth, so feel free to come after and maybe get a pair of socks or something else. This is a real attack that was detected by our platform, our cloud-based cybersecurity platform. So this happened this year. We had an attacker that was using an API vulnerability to send pairing requests to around 80 vehicles. So he just understood that the app allows him Ebola, that vulnerability, that he was just able to access different VINs that he's not associated with. So he's sending these requests to the vehicles through an API vulnerability. And the way it happens on the vehicle side is the fact that the driver gets a notification on his infotainment. The infotainment is the small computer that you use on your vehicle. So this guy understands that maybe people will be suspicious, and this pairing request comes from first name security, last name update, please confirm the pairing. And when the driver sees this, most of the drivers are innocent. They don't expect this kind of hacking to happen through your vehicle, just approve it. The minute they approve it, the attacker gets access to the vehicle. He removes the original's driver credentials. So now he's the owner of the vehicle. He takes over of the account. So he's had access to all the data that was there, where the driver drove to, and he can send remote commands to the vehicle. So now he can lock the vehicle. The driver can't get to the car. He can, if the vehicle is driving, he can send remote commands like open the doors, lock the doors, open the windows, switch on the air conditioner. And when we're talking about a physical product that is driving on a highway, this can really have a significant impact.
A problem.
Yeah. So Upstream platform detects it in a matter of minutes. Why? Because we're seeing an abnormal activity of one user that is getting connected to a significant amount of vehicles in a time interval. We create an alert, and in a matter of minutes, we are able to mitigate it, remove the attacker's access to these vehicles, restore the credentials and all the data to the OEM. And we're also going to talk about like how we can do this integration with AWS and the rest of the
I
talk.
can't wait. So far we talked about the impact, right? We talked about the latest incident. We talked about the operational and business impact. We talked about the vehicle and driver safety, right? And we also talk about data leakage and brand reputation. But we talked a lot about the problems, right? I'm asking, are there any good news?
Yeah. So let's start from the fundamentals. So don't be too afraid of this diagram. I'll walk you through. This is a canonical vehicle application. So say you want to build a companion app, and we're going to go through a very simple example of remote starting your vehicle, right? You could fill that in with anything you like. On the top of this diagram is where the consumer application lives. This is a mobile app where you can send commands to the vehicle. On the bottom is your vehicle. Your vehicle can connect to AWS in lots of different ways. I decided to pick a certain type of protocol. It could be many protocols, but your vehicle is going to receive that request and do something, right? So you have sort of these two coexisting applications that are running on the vehicle. So let's talk a little bit about the putting into practice what Shakar is talking about. So we looked at the OWASP top 10, right? So Shakar talked about resource exhaustion. So what you don't want to allow is attackers to come in and start to exhaust your resources. So you need to serve traffic in a way that will allow for your application to scale. So you may want to put something like a CDN in front of it, which is called a content delivery network. And you want to make sure that you put denial of service protection on your CDN, or if you don't use a CDN, make sure that your API or your front end is protected. So that way attackers can't just keep hitting this endpoint endlessly with as much data as they want. If you move to the right of this diagram, this is table stakes, right? So what we're saying is, okay, so now I have DDoS protection, but what am I, from a networking perspective, what am I allowing? Am I allowing certain ports and protocols that I shouldn't allow? So you need to put a firewall in between, essentially protecting your load balancer or your front end when attackers or users that are authorized are making requests. They're not able to communicate to ports and protocols that you don't want them to communicate to. As we continue to shift into the story, okay, now we've got the request. We made sure that the ports and protocols are secured. We have a content delivery network. We are protecting against denial of service. And then we start to see very strange types of queries coming from this user, right? They may put something like, give me back this particular VIN and give me back a bunch of different VINs. So I'm going to put a star there to retrieve back all different types of VINs. Okay, this is a very serious problem. You can see these in the examples that we talked about. So we should protect the application code from allowing that, but we should also put a web application firewall to say, I don't want to see that query. That shouldn't be allowed. So we should see that query, evaluate it, and block it. And so those are things that you need to understand about web application firewalls. They can help you as a second line of defense. Your code is the first line of defense. Moving on to the last step here, this is identity, probably the most important thing. What I see my customers do that I make sure that I understand very clearly is do not make up your own OAuth and authorization schemas. Don't try to do something that is not part of an industry standard. This is a place where you make massive mistakes. So you have to authenticate and authorize your users. Every user has to be authenticated and authorized. So what does that mean? Let's walk through a very simple example. I open up my application. I want to start my vehicle, right? Well, first I have to authenticate. Okay, my name is Omar Zoma. Here's my password, right? Now I'm into my application. I've been authenticated. I used industry standards to get me authenticated. Now I want to make a command. Okay, your API should answer the question, can Omar start his vehicle, yes or no? If the answer is yes, that's great. So I press the start button, my vehicle starts, right? But that's not enough. And the layer that Shakar was talking about called BOLA, broken object level authorization, you have to think about now, okay, I'm allowed to start my vehicle, but can I start Shakar's vehicle, right? So this is a whole nother angle. This is, okay, I can do something, yes or no, but to which vehicles can I do it to? So you can see the different layers. Like, it's not just authentication. It's not just can I start my vehicle, but it can become a very complex situation where you have to understand those things. And this is why I think our partnership is so important, because we can help you on AWS be more secure fundamentally and shift left. But what happens when we shift left, but now we're still seeing that our APIs are accepting requests that they shouldn't? So how do we understand what the context should be as opposed to just table stakes putting in a CDN, right? It goes beyond that. So, and Shekhar, you'll talk more about that.
Yeah, so I think we mentioned context many times, and the context of this conversation is automotive, mobility, and everything that moves. And I think the way we see this kind of partnership is the fact that we add another layer that is upstream cybersecurity layer for the automotive. So the API security solution that we're talking about is part of Upstream's VSOC, Vehicle Cybersecurity Operations Center. This is our cybersecurity platform that is already being used by 15 global OEMs. So it's a lot of brands. And we're already monitoring live 25 million vehicles. So just to connect it, 25 million vehicles is 10% of all the connected vehicles in the world today. When I'm looking at what our platform enables you, I'm just going to focus on 3 features. And I think that really connects to the fundamentals that we're talking about. First of all, manage your API inventory. That's the first step. You don't understand like how it really helps you to solve 60 or 70% of your issues. And like when we're talking to OEMs, when we're talking with smart mobility players, and we ask them to see their inventory, and then we start mapping the data that we receive from their gateway, it's a horror show. Really, like wow. I thought we deleted that like 3 years ago. No way 10,000 users use it on daily basis. Like, hey, this was only supposed to return like this specific field. Why it returns like 10 different fields? Like looking at the users, it's really creating visibility. I'm a data person. I love that moment, and I think this is like the first thing you need to do. Once you have an understanding of your inventory and you're starting to manage it, the second step that I think is like we're talking a lot about shift left. You need actionable data to shift left. Okay, if you don't have that, it's just a buzzword. So from our experience is that when we're working with the security teams, they want to create a change in their organizations, and they need tools to do it. What Upstream platforms and API security application can do is help the security teams to have actionable documentation for their APIs. So when a security team reaches a developer and says, hey, we have these APIs, shadow APIs that aren't supposed to work, and people are using them, the platform generates automatically documentation for those APIs and proof why they are used. And this is really a killer feature for our OEMs and our counterparts to manage their APIs and to deal with this challenge. And the last thing we're talking about through the whole session is context. API security has to happen in a context. And when I showed that example of a user that is pairing to 80 different cars, when I'm talking about a generic API solution, it's 80 different IPs. So that is legit. Like when I'm looking at servers, when I'm looking at IT, pinging like 80 different IPs is great. But when I'm looking at a fleet and I know that behind these IPs or behind these identities there are vehicles, then that really draws the line between missing an attack or detecting a wide-scale attack on your fleet. And what is amazing that with the fact that we are dealing with mobility and dealing with connected cars is the fact that you can take the API data and fusion it with the telematics data. So you're seeing like the whole picture, not only the API calls, but also what is collected from the infotainment, the over-the-air updates. We're talking about SDV, all of that in one single app.
So I love what you did there. I'll take your example of the house. First thing, get your house in order, know and manage your APIs. Second thing is really, get some ammunition, right? So get your SecOps team the ammunition to go back to the developers and get the SecOps done. And the third one is context, right? Okay, so let's talk about our partnership, Omar. And sure. Thank you so much for your partnership, by the way. Tell us a little bit about how we work together.
Yeah, absolutely. So I think, I'm trying to, with Upstream, a leader in the industry, to bring security to the forefront. And at AWS, we use the term that security. We say job zero or the most important thing, right? So security is the most important thing because everything starts with security. And this is our strategic workloads in AWS Automotive. And we are particularly focusing on and even expanding upon a partnership to understand how do we protect vehicles in the field? How do we protect the APIs? What is the right way to build a connected mobility platform? And so with Upstream as a partner, this is helping us really accelerate some of our offerings and help our customers become more secure as they're building connected mobility applications in the cloud.
Great. Shahar, maybe you can talk a little bit about the architecture overall, not going in too many details, and then maybe you can take later on about how does that connect all together.
Definitely.
So to simplify things as much as we can, Upstream can be easily deployed on AWS. So when our customers are using AWS, the customers can benefit the collaboration between Upstream and integrating the services. So one of the issues that we are encountering in the automotive industry and with OEMs that there's many data sources and these data sources are scattered all around and nothing is unified. So when we have a customer on AWS, it's much easier for us to deal with it, and all the data can be integrated into our platform in matter of hours. So when we onboard a customer that is on AWS, it really makes life easier for us and as a partner. And so on one hand, you have the data that is integrated into the platform, visible, you have everything there. And once there is an alert, the amazing thing, and that is the other sign of this partnership, is the fact that an alert can trigger an action using AWS components. So let's head to the next slide, and I want to show
one input. Okay. I think that I won't name names, but one of the guys who are presenting here, lovely cars, were able to onboard more than 5 million vehicles in less than 24 hours, right? And that's amazing. And I think that talks loud about the partnership, about the ability to really fast track not only the cybersecurity compliance, but the ability to monitor attacks. But what happens when you get breached, right? What happens when you spot an attack? Tell us.
Yeah, so at AWS, we try to innovate a lot and try to understand how do we protect our customers. And ultimately, the central platform is Upstream cybersecurity platform. So they're going to ingest data at scale, and they're going to tell you about things like context and what your APIs are doing and why. And then they will generate a finding for us. So ultimately, what our goal is we have to give customers the option and the flexibility to do something with those findings. So what this diagram is showing is Upstream will provide us with a finding. The middle diagram is our detection platform called Security Hub, or it can be any SIM you want, right? It doesn't have to be our service, but we have a service called Security Hub that will accept findings from Upstream. And you can do this today. It's a format that you will create, an API, one API call, you have the format, and then you get that finding. And then the beauty of AWS, of course, is on the security side, we are all about automation. So what happens now? So vehicles connect in many different ways. Our users are communicating to the APIs in many different ways. And say, for example, we talked about the remote start use case, right? So millions of users are hitting start the vehicle. One user is starting millions of vehicles. And we get that finding from the Upstream platform. It goes into our detection platform. And then you can take action. You can block that request because you have the context. You might want to add a custom rule to our web application firewall. You might want to stop the vehicle from accepting those requests. Maybe you temporarily inactivate the certificate using our IoT Core platform. So because of Upstream, as well as our remediation and automation, you can actually do things like contain the vehicle, you can change permissions on the user, and this is a very powerful piece of the puzzle. So we talk about this end-to-end remediation.
Yeah, just to add on that, when we're talking about managing cybersecurity, managing a VSOC, one of the best tips we provide is make the right thing the easiest thing to do. And in this case, when we're mentioning automation, managing a VSOC is a hard thing. Managing API security is a tough challenge. And automation here is the key to deal with that. And we don't want to be in a point where we're we're having a high severe alert and we have someone in the vSOC that has no idea how to deal with it, and the fact that we're having automation will really help to avoid these kinds of attacks. So I think that this integration, the fact that we have an alert that is able to trigger an action using AWS security components is just an amazing.
And I think you showed me earlier on a video of a future thing about integrating generative AI into the remediation process.
Yeah.
Can you give a teaser? I know that you're showing this in the demo booth, but can you tell a little bit about it?
Yeah, so this is just something we didn't plan to show here because we didn't know if people will be here or be engaged to see it. But part of what we tried to create is using Gen AI to help vSOC manage their operations. And we understood it's a tough challenge. So we have a text box that the vSOC manager can use just to ask like the system, what are the most significant alerts I have? How can I investigate them? How can I remediate? Everything is based on our playbooks, and we're using that to integrate actions using AWS components.
Amazing. Well, wrapping this up, right? I was a little bit anxious earlier on when you talked about all the challenges, but I feel at least for now, that the future is bright. There's a light at the end of the tunnel, and it's not a train coming, right? It seems like AWS and Upstream are able to help customers really fast-track their onboarding of API security, vSOC, and cybersecurity. So with that said, I want to give our panelists a big round of applause. Thank you so much for...
Absolutely. Big round of applause for all of you, including you, Arnon.